Okay, class, in this lesson, we are going to learn to calculate the volumes of a sphere as well as solve problems involving the volumes of spheres. Before we get started, let's go ahead and define the volume of a sphere, and that is V is equal to 4/3 pi times the radius cubed. Okay, so that is the volume of a sphere. Now there are two other equations that we're going to need to know for this lesson, and that is the surface area. Okay, surface area is equal to 4 times pi times radius squared. Okay, so that is the surface area of a sphere. And then the last equation is related to science. You may have learned this in chemistry or physics, and that is the equation of density. And that is density is equal to the mass of the object divided by the volume of the object. Okay, all right, so let's go ahead and get started with the first example. Okay, here we are told that the drama club makes a big ball from foam to hang above the stage for a play. They plan to cover the surface of the ball with metallic fabric. And the question is, what is the minimum number of square meters of fabric that the club needs of the volume of the ball? I'm sorry, if the volume of the ball is 1.8 meters cubed. Okay, so here we have a picture of the ball. And in order to solve the minimum number of square meters, we're going to need to know the radius of the sphere. Okay. Now, the only information that we are given is the volume of the ball, which is 1.8 meters cubed. Okay. So we can use the equation of the volume of a sphere to arrive at the radius. And then once we have the radius, we can solve for the surface area. Okay. So here's what I mean. So the volume of a sphere is equal to 4/3 pi times the radius cubed. Okay, we are told that the volume of the ball is 1.8 meters cubed. So we can substitute volume for 1.8, set that equal to 4/3 pi r cubed. Okay, we can now solve for the radius. And to do that, we are going to move this 4/3 to the other side of the equation. And we do that by multiplying both sides by 3/4. And when we do, these cancel out and these cancel out. And now we're left with 3, let's do this in the right color, 3/4 times 1.8. And that's going to equal pi times r cubed. Okay? All right, so let's go ahead and multiply out 3/4 of 1.8. So 1.8 times 3/4 works out to 1.35. And that is going to equal pi r cubed. Okay, now we got to move pi over to the other side, and we can do that by dividing both sides by pi. Okay, and when we do that, we effectively cancel the pi's out on the right side of the equation, and what we have left is 1.35 pi. Sorry, 1.35 over pi is equal to r cubed. Okay, now if we use 3.14 for pi, we can simplify 1.35 divided by pi to 0.43. Okay, and that's equal to radius cubed. Now to solve for r, we need to cube root both sides. Okay, we're going to cube root it. And our radius ends up becoming 0.75 meters. Okay, so now that we know the radius, we can now calculate the surface area of the sphere. Okay, and so the surface area equation is 4 pi r squared. Okay, we just solved for radius, and so our surface area is going to be equal to 4, and we're going to use 3.14 for pi, and then we're going to take the radius 0.75 squared. Okay, so if we multiply this entire thing out in the calculator, we get 7.07 square meters. Okay, so let's take a look at the problem again. What is the minimum number of square meters of fabric that the club needs if the volume of the ball is 1.8 meters cubed? Okay, so then our answer is going to be 7.07 meters squared of fabric. Okay, all right, let's move on to the next example. So here we have a fairly straightforward question, and the question here is, what is the volume of a hemisphere with a radius of 4 feet? Okay, what is the volume of a hemisphere? So if you take a look at the word hemisphere, we see that we have a prefix of hemi, and that really means half. And so we are looking for the volume of a half of a sphere. And so to solve this problem, we're going to start again with the volume equation of a sphere, and that's 4/3 pi r cubed. Okay, and so the volume with the radius of 4 feet is going to be 4/3 times pi times 4 cubed. Okay, now using 3.14 for pi, we're going to get an answer of 267.95 cubic feet. Okay, that's the volume of a sphere. Remember, we're looking for the hemisphere, so half of that will work out to, so I'm going to say the volume of a hemisphere, and we'll just I'm going to abbreviate this as HS. Okay, is going to equal half of the 267.95 that we just calculated, and that works out to roughly 134 cubic feet. Okay, all right, and then the next question is, what is the volume of a hemisphere with a diameter of 13 centimeters? Okay, so we know that, or at least we should know, that the diameter is equivalent to twice the radius. Okay, so that means that the radius is going to equal half the diameter. Okay, since we are told that the diameter is 13 centimeters, what this means is that the radius is going to be half of that, or that works out to 6.5 centimeters, which is our radius. Okay, so now that we know our radius, we can go ahead and plug that into the volume equation of a sphere, and that's 4/3 pi r cubed. Okay, and our radius, we know from what we just calculated, is 6.5, and that's going to be cubed. And assuming that we use 3.14 for pi, this works out to 1,149 point, I'm going to round this to the nearest tenth, so it'll be 0.8 cubic centimeters. Okay, and remember we're looking for the volume of a hemisphere, so we're going to need to take half of that. So we're going to call this V sub HS for hemisphere, and that's going to work out to about 575 cubic centimeters. Okay, all right. Here's example 3. In this example, we are told that a solid is composed of a right cylinder and a hemisphere. Okay, so it's pictured over here, a cylinder and a hemisphere. Okay, and the question here is, if the density of this solid, right, so the density of this entire thing is 100 kilograms per meters cubed, what is the mass of the solid? Okay, what is the mass of the solid? Okay, so if you recall, as I mentioned at the very beginning of this lesson, the density is equal to mass over volume. Okay, we are given the density, which is 100 kilograms per meters cubed, and we want to solve for mass. Okay, so to solve for mass, we need to multiply this equation by volume on both sides, and we get that the mass is going to equal the density times the volume. Okay, we already know what the density is. That's 100 kilograms per meters cubed. We don't know what volume is, but if we did, we would know the answer to the mass of the solid. Okay, so then ultimately we need to solve for the volume of this solid. Okay, now we are told that this volume, or the solid, is made up of a right cylinder that has a diameter of 2 meters and a height of 3 meters, and it's also made up of a hemisphere. Okay, so let's go ahead and solve for the total volume of this entire solid. So we could say that volume total is equal to the volume of the cylinder plus the volume of the hemisphere. Okay, the total volume is going to equal the volume of the cylinder, which is the area of the base. So we're going to say pi r squared times the height plus the hemisphere. So that's going to be 4/3 pi r cubed times 1/2, because we're taking the volume of a hemisphere, which is half of a sphere. Okay, so if we were to rewrite this, this will be pi times the radius. We're told that the diameter is 2 meters, and so therefore the radius is going to be 1 meter. So that's going to be 1 squared times the height, which is 3 meters. And we need to also add 4/3. Okay, we have 4/3 times 1/2, so we can go ahead and simplify that into 2/3 pi, and then the radius radius cubed. Well, the radius of this hemisphere is half of this diameter, so that's going to be 1 times 1 cubed. Okay, so if you go ahead and punch that into the calculator, well, actually, let me go ahead and simplify this first. This is going to work out to 3 pi plus 2/3 pi. Okay, so adding those together, we are going to get and assuming that we're using 3.14 for pi, okay, if we punch that into the calculator, we're going to get 2 times 3.14 divided by 3. Okay, that works out to 11.5 meters cubed, okay, or cubic meters. So now we know that the total volume for the solid is 11.5. So we can go ahead and substitute that back in. And so now we have 100 kilograms per meters cubed times the volume, which we calculated to be 11.5 meters cubed. And the mass is going to work out to be 1,150 kilograms. Okay, and then our unit measure works out to be kilograms because we have meters cubed up here in the numerator and meters cubed down here in the denominator, and therefore we are able to go ahead and cancel that out, and then we're left with kilograms. Okay, hopefully that made sense. If any of this was confusing, please go back to the beginning of this recording and listen to it again. Thank you.